Hello there. You are welcome to the third session of Unit 5. In this session, we are looking at engaging in mathematical analysis. Let's look at the session objectives. At the end of the session, you should be able to gain some skills necessary to engage in mathematical analysis after identifying a topic to teach from the syllabus. In our previous session, we talked about curriculum analysis of specified topics in the JHS mathematics syllabus. We focus on what we want students to know and be able to do. The subject matter of mathematics involves the learning of various things such as mathematical concepts, principles or conventions, meta-mathematical practices like reasoning, abstractly, generalizations, and skills. In other words, in our previous sessions, we looked at the three kinds of subject matter that can be taught to students. And we talked about concepts, generalizations, and skills. Some topics are more likely to highlight a particular subject matter than others. In other words, some topics in the syllabus, when you look at them, some are more likely to highlight a particular subject matter than others. So those that are likely to do that is very clear. Those that are not, it is up to you as a teacher to identify the kind of subject matter to teach in that regard. So as a math teacher, you should be able to determine what subject matter is being emphasized for each topic so that you focus on that. So you look at the topics in the JHS syllabus and look at what subject matter is being emphasized for a particular topic. Is it a concept? Is it principles or conventions? Is it generalizations, skills, whatever? So you have to look at that and be able to determine what subject matter is being emphasized. So knowing the what about the topic to be stressed, is it a skill? Is it a concept or a generalization? So knowing this is an important part of the teaching process. The what about the topic to be stressed. What are you going to stress about the topic? Is it a concept? Is it a skill? Is it a generalization? It's very important factor to be considered in our teaching and learning process. So let's look at what we mean by mathematical analysis. So knowing what about the mathematics topic to teach and how to teach it so that it is in line with the general aims and objectives of the mathematics syllabus is what we say constitutes mathematical analysis. So in mathematical analysis, you as a teacher have to know what about the mathematics topic you are to teach. How do you teach it? How do you present it? Using different presentation skills and presentations. How is it going to achieve the aims and objectives of the mathematics syllabus? Because that is what is your guiding principle. That is what you use to evaluate or assess whatever you teach. So knowing what about the mathematics topic and how to teach it is what we say constitute mathematical analysis. So as we did for the previous session, there are some key questions to ask when doing mathematical analysis. And you are going to look at 3 questions that you should consider when you are engaging in mathematical analysis. The first one is, what are the key mathematical ideas of the topic to be treated? So when you take any topic, you ask yourself, what are the key mathematical ideas of the topic to be treated? And by this, we mean that for every topic, you have to clearly indicate what it is that students should know and be able to do. What it is that students should know and be able to do, as we looked at in our previous session. For example, the topic space and shape, which is in JHS 1 syllabus, and the specific reference number is 1.4.2. In our previous lesson, we explained what these 3 digits stand for, and that is JHS 1 Unit 4 specific objective number 2. And it states that the pupil will be able to find the relation between the number of faces, edges, vertices and vertices of solid shapes. So if you are asking a question about this topic, our first question says, what are the key mathematical ideas of the topic to be treated? So if you take a topic like this, space and shape, with that objective or specific objective, then you begin to ask yourself some questions. And you can ask yourself questions that what is the key thing students should learn about this topic? Is it the meaning of face, edges, and vertices? Or is it about the meaning of solid shapes and examples of solid shapes? So if you're able to determine the key mathematical idea that students should be able to learn, then you are on your way in doing mathematical analysis. So the answers to some of the questions that I've asked, are we talking about the meaning of face, edge, and vertex of solid shapes? Or we are talking about solid shapes and examples? Or we are talking about the patterns or the relation between the number of faces, edges, and vertices? If you're able to provide answers to this question, that will determine what you focus on in your instruction or in your teaching process, and what you may take as RPK and so on. So if the particular topic is asking for the relation between number of faces, edges, and vertices of solid shapes, then the students must know what solid shapes are. They should be able to give examples, and so this one shall be considered or can be considered as your RPK, and then you are able to do your mathematical analysis in that regard. The second question you should ask when doing mathematical analysis is, what different representations will you use? You know, in teaching mathematical concepts, you can use so many representations for one concept or one topic. In each topic you teach, you can use many representations. So what will be the best way to represent a subject matter? So depending on the kind of subject matter you're presenting, what is the best way to represent that subject matter? And Lesh and Daw 2003 highlights a number of representations. You can look for other highlights from other experts in the field, but we are looking at what Lesh and Daw 2003 proposed as a way of representation. And this way we can represent our subject matter by using equations, by using tables, by using graphs, by using written symbols. Others include using spoken language, that's just explaining the concepts, diagrams or pictures, use of metaphors, and concrete models. So all these things are ways by which we can represent or present our subject matter to our students according to Lesh and Daw. And others have also proposed different ways that we can use. So it is up to you as a teacher to look for such ways of representation and look at which one will best suit your students. Students learn best when we teach using different representations for the same concept. So according to the proposers of this, they are saying that when we use different types of representations of the same concept, students learn best. You have to decide what the best representation to use. So when you take every concept or every topic in the syllabus, you look at how am I going to present this concept. For example, if you are teaching simultaneous equations, are you going to use equations, tables, graphs, written symbols? You know, you can draw the graphs of the linear functions and then you look at the intersection. So you can use the graph to explain simultaneous equations, which are equations in nature. So you can use equations, and you can, for each equation you take, you can draw a table of values for it. So you are using equations, table and values, and then you draw the graph, and that will explain the concept better. You can also use spoken language. So in the course of the lesson you are explaining. So you see that you can use so many representations to teach that particular concept. So another example is shape and space. You can use concrete materials. So you take concrete materials. If you are teaching shapes like solid shapes, you take concrete materials to the class, or you can use concrete, semi-concrete with the help of technology. PowerPoint presentation, you can get a lot of semi-concrete materials, pictures of concrete materials, and then use it to represent or present your concept. The general principle is to use as many different representations for the same concept as possible. So as practicable as it is, as much as it is practicable, you have to use so many or many different representations for the same concept, as I've explained in the examples that I've given earlier. If you are teaching a concept like solid shapes, you can send concrete materials to the class. You can use semi-concrete materials. You can use spoken words. All these things will explain the concept to the students, and this will make sure that students can see and make necessary connections, and also has a potential of, if you do that, it has a potential of helping you meet the diverse needs of students. You have different categories of students in our class, and using different representations will help meet the diverse needs of our learners in the classroom. So as a teacher, you should also study the syllabus with the intention of deciding what is the most appropriate way to teach. So it all depends on the subject matter you are presenting to your students. The third question you should ask is, what important connection exists with other topics? By this, we mean that mathematics as a discipline is like a structure with each brick connected to others. As I said in our previous sessions, doing mathematics is just like building a house. If the foundation is weak, you cannot build any strong structure on it. So you have to, teach mathematics as if you are building step by step in that order and connected in that respect. And the beauty of mathematics is seen when we teach it as a connected body of knowledge. So when you teach the mathematics as continuous something connected, then the students start to see the beauty of the mathematics you teach. Rather than teaching them separately, you teach linear equations, you don't connect it to other topics such as simultaneous linear equations. You teach algebraic expressions without connecting it to other concepts. The students see it to be separate entities, and therefore there is no connection in knowledge. Example is the connection between linear equations and linear inequalities. So you see that the only difference between linear equations and inequalities is the equality sign, which is changed to inequality symbol. So there's a connection. The way we solve linear equations, the same way we solve linear inequalities, except when you are dividing or multiplying both sides by a negative number. And you have to connect the two so that the students will see that they are not separate entities but connected. And then you can talk of linear graphs and simultaneous linear equations, as I've already explained. So if you do that, if you're able to connect the concepts or the topics, then the students will be able to appreciate what you are doing, and it will avoid over generalizations and rote learning. So all these things come together to make or to show the beauty of the subject that we are teaching. So in conclusion, mathematical analysis, your focus is determining what about the topic, what is critical that you are going to teach or essential for students to learn. Mathematical analysis focuses on the mathematics to be taught, whilst curriculum analysis focuses on the topics in the syllabus, how you are going to analyze the topics. So mathematics is a study of connected ideas, a beautiful edifice where the various parts are connected, as we have already seen. And make sure that your students get to see this connection so that mathematics becomes a meaningful subject. And I believe and trust that as future teachers, you are going to take note of these points and make mathematics a beautiful subject to your students. With that, we have come to the end of today's session. I'll leave you with 2 questions. Look at them critically. When we meet, we shall discuss.